And now we're going to talk about actually shifting, stretching and shrinking reflecting functions, and then describing transformations. And you can do these by graphing them in Desmos and seeing what happens, or how to get this to translate 4 units up, for example, for this first example. Or you can do this very algebraically, so you can do either one. So in this first example, we're going to suppose that a function f of x equals 3x minus 6. And we're going to apply these separate transformations to it. So we're going to write g of x, a function g of x, if f of x is translated 4 units up. So we'll talk about this algebraically, and then we'll go to Desmos and make sure we're right. So let's see, so g of x, we need to go up 4, which means we're going to take f of x and add 4. So this means that g of x equals 3x, negative 6 plus 4 is a minus 2. So let's go to Desmos and make sure that we shifted 4 units up. So this is 3x minus 6, and our transformation is y equals 3x minus 2. Did we go 4 units up? Let's check out these intercepts. This one is at negative 6. This one's at negative 2. Went up 4. Perfect. That's what we needed. All right, next one. Write h of x if f of x is stretched vertically by a factor of 2 and reflected in the x-axis. An important thing to remember that with vertically stretching or shrinking and reflecting the x-axis, our rules are, okay, so I'm just going to combine them. So our new function would be negative a times f of x. And keep in mind, we're going to multiply this negative a times the entire function f of x. So we're going to apply that. So we're going to write h of x is equal to, okay, we're going to stretch vertically by a factor of 2 and reflect in the x-axis. This is going to be a negative 2 times our entire original function, which is 3x minus 6. And now we're going to simplify. You can, although it's very easy to see these transformations if you don't simplify. But this will be negative 6x plus 12. You can double check this in Desmos. So I have red is the original function, green is the new function. And let's take a look at, what is this? X equals 4. Let's just take a look at one point. So this point should be stretched by a factor of 2 and then reflected, which means that it should be negative and then double this red one. So let's check this y value. This is negative 6. To stretch this vertically by a factor of 2 means that we have to be stretched away from the x-axis double, which would bring us to 12. So normally it would be up here, but then we reflected over the x-axis, which brings us down here to negative 12. And that's a way you can check to see if your transformation actually worked. Just pick a point. Just pick a point of both those functions and see if you actually did stretch it by a factor of 2 and if we actually did reflect it in the x-axis, which we did. So we're good. That one is done. And now we're going to write a function v of x if f of x is horizontally stretched by 3 and moved right 6 units. Okay, so as a general rule, this is going to be f of horizontally stretched by a factor of 3. Horizontal, the factors are reciprocals of what they would seem to be. So we're actually going to multiply by a 1/3 to horizontally stretch this. And then times every x. And we need to go to the right 6. So that'll be minus 6. All right. So let's apply this function and then double check our work in Desmos. So this is v of x. This means we're going to replace every original x with 1/3 x minus 6 equals, so this will be 3, and then 1/3 x minus 6 double parenthesis, and then minus 6 down here. So I can simplify this as 3, 1/3 times x is 1/3 x, minus 2, 6 times a third is 2, minus 6, and then this becomes x. That'll be minus 6 minus 6, that'll be minus 12. And that'll be our function v of x. And you can double check that one in Desmos and see if it actually is horizontally stretched, so stretched away from the y-axis and then moved right 6 units. So let's keep going. Let's move on to describing transformations. So objective 2, I can describe transformations. So from the parent functions, we're going to describe the transformations to a and b here. So let's start with a. The parent function is, I'll write it as g of x, equals, you see we have a squared here, and x is inside. That means this is going to be x squared is the parent function, a general quadratic equation. So keep in mind, we've got a 3 here, we've got a minus 4 here, and got a plus 3 out here. And we need to figure out what each of these numbers will do to the graph. And we can graph this, or we can use our rules. I'll just use the rules, and you can double check by looking at the graph. So let's see, start on the outside. We'll start with this 3. So that will be a vertical shift up 3 units. Now I'll change colors. This minus 4 in here will be a horizontal shift and it's minus, so that means we will go to the right 4. Finally, we've got this 3 out front, which will be a vertical stretch by a factor of 3. Those are our 3 transformations. I'm going to erase my markings really quickly here, but this is a quadratic equation written in vertex form, which is really useful because this means that the vertex is at 4, 3, because we went up 3 and right 4. And a vertical stretch by a factor of 3 means that it will appear thinner. It will appear closer to the y-axis because those y values are stretched away from the x-axis. All right, now let's take a look at g of x equals negative e to the power of x minus 1 plus 3. So let's take a look at this plus 3. This is a vertical shift up 3. And then we'll take a look at this minus 1 in here. Oh, excuse me, I guess I should have started that the parent function is e to the x. So this x minus 1 is in this original x term, which means this will be a horizontal shift. This minus 1. It's minus, which means we'll go right 1 unit. Finally, we have this negative sign, which I'll write in a different color. We have this minus sign, and it's not dealing with our x term in here directly, which means it's on the outside of our function. So this is a reflection in the x-axis. So each of these functions had 3 different transformations, and each part of the function, or each addition to the parent function, so we had a minus 1, a plus 3, and a negative sign, did something different to the function. So yeah, so that'll be it for function transformations in this video. As always, email me if you have any questions at all.